and second type of diluted electrolytic solutions. So first we take concentrate NaCl solution, and concentrate means how much it is concentrate. It is the saturated solution of NaCl. It is the saturated solution of NaCl. Now the situations will change. The situations that we see in when we take NaCl and take platinum electrode, then in second example we take MgBr2 and the rods rods was platinum rods, and in third electrolysis of AlCl3 we take platinum electrodes. Now here the situations are different. So what are the situations when the electric current is passed through the saturated solutions of NaCl? Saturated solutions of NaCl, when electric current is passed through the electrolytic solutions, then the following reactions will proceed. Means NaCl in electrolytic solutions, NaCl is present, and NaCl dissociate into Na plus and Cl negative ions. When electric current is passed through the electrolytic solutions, and the electrodes are taken in as inert electrode. This is the inert electrode, platinum electrode, and water also present in aqueous means saturated solutions. How we form a saturated solutions of NaCl means we have to pour the NaCl. A large quantity of NaCl is poured in the water. Then a conditions will come when no more of NaCl can dissolve in the water, and that type of solution is a saturated solutions of NaCl. So when we when we start electrolysis of concentrate NaCl, then water is also present. Then water will decompose in the hydrogen ion and OH ion, hydrogen ion, H plus ion and hydroxyl ion. So at cathode and anode we get two different charges. Two different charges means both two charges, chloride and OH, both are negative charges, and negative charges goes to the anode side. These two charges will be present at anode side, and these two charges, sodium and H plus ion, are present at cathode side. They are present at cathode side. So what is the reaction at anode side and what is the reaction at cathode side? So at anode, the ions are present are chloride ion and OH ion. Chloride and OH ions are present at anode side, and the ions that are present at cathode side are sodium and hydrogen. So out of the two, which will oxidize? Uh, what happen at anode? Anode means PAO, PAO. Again and again I am repeating PAO. Positive anode oxidation means at anode oxidation will occur. So out of the two, chloride ion and OH ion, both ions are present. So which ion will oxidize and which ion will not oxidize? So to understand which ion will oxidize and which ion is not oxidized, we have to keep a electrochemical series. Electrochemical series we have learned, Lick Baka Namagal, that series we have remember. So it is the short form of that series. We have to keep in mind the only these elements. We have to keep in mind SRP. SRP means standard reduction potential. Standard reduction potential. These elements are arranged in the order of standard electrode potential, means lithium, then sodium, zinc, iron, hydrogen, copper, silver, chloride, hydroxide, nitride, sulfate, and chloride. These ions we have to memorize to find the product of electrolytic cells when two or more than two substances are present in an electrolytic solution. When two or more than two substances are present in electrolytic solutions, then which type of ions will oxidize at anode and which type of positive charge will reduce at cathode? To know that thing, we should know the electrochemical series SRP value we have to memorize. So this is the SRP value, and the elements arranged in the SRP value are the increasing order of their reduction potential. They are arranged in the increasing order of their reduction potential. Means lithium has least reduction potential and fluoride has most reduction potential. So reduction potential of fluoride is positive 3.05, and for lithium it is very less, minus 3.25, I think. So the elements or compound discharge at anode and cathode will be on the basis of preferential charge discharge method. This is the very important concept, preferential charge method. What is the preferential charge method? It is very simple, only name is complicated, preferential charge method. So we are going to discuss what is preferential charge method. So at anode, out of the two, we know at anode two ions are present, chloride ion and hydroxyl ion. So while one which one has higher oxidation potential will discharge. Out of the two, chloride and hydroxyl ion, the ions which have more oxidation potential will discharge. Here in SRP value, this is the least SRP to least reduction potential to higher reduction potential. When we go up to down, then the reduction potential increases. Reduction potential increases means oxidation potential is decreases. Oxidation potential are decreases. Here see in SRP series, when we move up to down, then reduction potential increases, means oxidation potential are decreases, means the element or the ions which have higher oxidation potential will discharge. So we have to move in this way, so the elements that are on top, see, this is the chloride and this is the hydroxyl ion. This is the chloride ion, this is the hydroxyl ion, and out of the two, chloride or hydroxyl ion which will oxidize. So chloride has less reduction potential as compared to hydroxyl ion. This means chloride has more oxidation potential as compared to hydroxyl ion. So here at anode side, chlorine will discharge. So the reactions will be Cl negative gives chlorine gas at anode side, and at cathode side, at cathode we know, and at cathode, see, out of the two, and cathode also has two type of ion, sodium ion and hydrogen ion. Out of the two, sodium and hydrogen, which ion will discharge is at cathode side, means the ions which have higher reduction potential will discharge at cathode side. So out of the two, sodium and hydrogen, sodium ion and hydrogen ion, which ion has more reduction potential? Which ion has more reduction potential? Means in SRP series, when we move up to down, then reduction potential increases. So reduction potential increases. This is the sodium and this is hydrogen. Moving from up to down, listen carefully. Moving from up to down, the SRP value are increasing. So SRP value are increasing. So out of the two, sodium and hydrogen, so hydrogen has more reduction potential as compared to sodium. So sodium, hydrogen want more electrons as compared to sodium. So hydrogen will liberated at cathode side. And how hydrogen liberated at cathode side? 2H plus ion accept 2 electrons from this chlorine and convert into hydrogen gas, and this hydrogen gas will liberated at cathode side. So at cathode side, the hydrogen gas will come out in the form of bubble, and at anode side, chlorine gas will come out in the form of bubbled gas. So at at cathode side we get chlorine gas, at cathode side we get hydrogen gas. So I think the point is clear to all of you. Now it's time to give your attendance. So net reactions are chloride ion, 2 plus ion, 2 plus H ion, we give chlorine and hydrogen, and in the solutions NaOH will be remaining. तो जो NaOH है ना बच्चों, देखो ये इसके अंदर तो क्लोरीन डिस्चार्ज हो गया. At anode we get chlorine gas. At cathode side we get hydrogen gas. तो यहाँ पे Na और OH ये क्या रह जाते हैं सॉल्यूशन में. तो Na and OH form NaOH. So solutions become alkaline. Solutions become alkaline after some time. This is the product of electrolysis of concentrated NaCl. So I hope the point is very clear to you. And next point is electrolysis of aqueous NaCl means diluted. Aqueous NaCl means diluted, means sodium chloride is very less amount in water. The amount of water is much more as compared to sodium chloride, and we take platinum electrode. The reactions will be NaCl will dissociate in Na plus and Cl negative, and water is also present in the solutions in much more amount. Then water will dissociate in H plus ion and OH ion. So both ions are present. 4 ions are present in the electrolytic solutions. So these two ions, chloride ion and OH ion, will move towards the anode side. These two ions move at the anode side, and 2 ions, sodium and hydrogen ion, move towards the cathode side. So the reactions will be like this. At anode we get 2 ions, chloride and OH ion, and at cathode we get 2 ions, sodium ions and H plus ion. So at anode we have 2 ions out of 2 which will oxidize. Which will oxidize means PaO, PAO, positive anode oxidation. Anode is positive charge, and oxidation will occur at anode side. So for oxidation we have to find the oxidation potential. Both of the two oxygen here. Here the situation is totally different. Here the situation is totally different. How the situation is totally different when we compare Cl negative and OH negative. See in this table, Cl negative and OH negative. So Cl negative has more oxidation potential as compared to OH negative. But in the case of aqueous NaCl, dilute NaCl, when we electrolysis aqueous NaCl, we get means water, OH ion, hydroxyl ion oxidize at anode side and not